Hello students, this is the continuation of class 10 chemistry chapter 1 chemical reactions and equations. In my previous class we have discussed about what is a chemical reaction and what is a chemical equation, and in the second part we have discussed how to balance a chemical equation. I repeat, balancing a chemical equation means making the number of atoms of the reactants equal to number of atoms of the products. Now there are some questions given in page number 6. So by solving these questions you will get more idea about balancing a chemical equation. Page number 6, question number 1. Why should a magnesium ribbon be cleaned before burning in air? It was given by me in my previous class. A magnesium ribbon is always rubbed with sandpaper or clean before burning because when magnesium is exposed to air, when it is kept in open air, it will react with atmospheric oxygen and a layer of magnesium oxide will be formed over it. Due to the presence of this magnesium oxide layer, it will not burn easily. So we are removing that magnesium oxide layer by rubbing it. That's why a magnesium ribbon is always clean before burning it. Question number 2. Write the balance equation for the following chemical reactions. Some chemical reactions are given. We are asked to balance it. But this time, chemical reactions are given in words, not in symbols and formula. So we have to change this words into symbols and formulae, then balance it. First one, question number 2, first part. Hydrogen plus chlorine gives hydrogen chloride. Hydrogen plus chlorine gives hydrogen chloride. A very easy question. First of all, you have to write the symbols. H2 for hydrogen, chlorine, Cl2 gives hydrogen chloride is HCl. So I have put the symbols. Now count the number of atoms in LHS and RHS. Hydrogen and chlorine are the two types of elements in this reaction. By counting the number of atoms, we get 2 atoms of hydrogen in LHS, but only 1 atom of hydrogen in RHS. 2 atoms of chlorine in LHS, only 1 atom of chlorine in RHS. So in RHS, the number of atoms are less. By how much? 2. Here it is 2, 2 and here it is 1, 1. So it is very easy to balance. When we put 2 here, 2 HCl, this 2 is applicable for both H and Cl. Now count the number. H2, H2. Cl2, Cl2. It is balanced. Question number 2. Barium chloride plus aluminium sulfate. Barium chloride plus aluminium sulfate gives barium sulfate plus aluminium chloride. Barium sulfate plus aluminium chloride. Yes, the first part is changing them into symbolic form. Barium chloride is BaCl2. In class 9 you might have studied how to make the chemical formula BaCl2 by writing the symbol and valency below it and cross multiply. Ba valency 2, Cl valency 1. Cross multiply Ba1 Cl2, that is BaCl2. Aluminium sulfate. Aluminium valency 3, sulfate valency 1. So Al sorry, sulfate valency 2. So Al valency 3, sulfate 2. So Al2 SO4 thrice is aluminium sulfate. Al2 SO4 thrice gives barium sulfate BaSO4. Aluminium chloride AlCl3. Now see the balancing. Count the number of atoms in LHS and RHS. Ba, same. Cl2, but here it is Cl3. Number differ. Al2, here it is only Al. SO4 thrice, here it is only SO4. Either we can consider S and O separately, or we can also consider SO4. Now, everything is unequal on both the sides. So let us try to make it equal by taking one by one. Let us take Ba first. Here it is Ba, okay. Ba is equal, but all other atoms are different. Cl2, Cl3. We know that 2 can never be equal to 3, because if we write anything, then we will be writing it here. So the first number that we can try is 2. When we write here 2, it will become 2Cl2, that means 4. But here the problem, 3 can never be made 4 by writing any number here. So in such cases, we have to see the LCM. 2 and 3 can be made equal if both of them can be made 6. Is it? Otherwise, if you write anything before 2 and if you write it 2, then it will become 4, but 3 can never be made into 4. So if it is 2 and 3, we can make both of them equal to 6. How can we make them equal to 6? Here we can put 3 and here we can put 2. So now the number of chlorine atoms are over, equal. 3Cl2 means 3 into 2, 6 Cl atom. 2 into 3, here also Cl atoms are 6. But while doing so, other atoms are also get disturbed. For now it is 3Ba, but here we have only Ba. Now we have to make Ba equal. How? Since it is 3 here, let us also try 3 here. Okay, so 3Ba, 3Ba. But remember, this 3 is applicable for this SO4 also. SO4 also become 3. But here already we have SO4 3. Now let us try once again. But 3Ba, 3Ba. Cl6, Cl6. 2Al, 2Al. SO4 thrice, SO4 thrice. Now it is balanced. So this is the method. We have to put different numbers before the formula, and sometimes it can go wrong, no problem. You may try by different numbers. If not getting equal, then rub it and try by another number. For example, while making one thing equal, the other thing will get disturbed. So don't worry. Sometimes you have to remove that number by seeing the other atoms. So it will come by practice. So now it is balanced. Count the number of atoms of each element in LHS and RHS. You can see that they are equal. Question number. Now, there is a third question also. Sodium plus water gives. Third one. Sodium plus water gives Sodium hydroxide plus hydrogen. Sodium hydroxide plus hydrogen. Sodium Na, water H2O, sodium hydroxide NaOH, hydrogen H2. Now count the atoms in LHS and RHS. Na equal H2, but here it is 1 plus 2, 3. Hydrogen atoms are not equal. In LHS it is 2, but in RHS it is 3. O, here it is only 1 O, here also it is 1 O. Now, what is not matching? H2. Number of hydrogen atoms are mismatching here. 2 plus 1, 3. So, 3 and 2 cannot be made equal. If we give the minimum number here, then it will be the minimum number that can be given is 2. Then what is the number of hydrogen atom now? 4. Now count here 2 plus 1, 3. Not equal. So how can we make that side also 4? By putting 2 here. Now count 2 into 2, 4. 2 plus 2 equal to 4. Now hydrogen atoms are equal. But what happened? By writing here 2, Na and O also got double. Now it is 2 Na. But here it is only 1 Na. So here also we have to put 2. Now 2 Na, 2 Na. Hydrogen is already got balance 2O, 2O. Now count the number on LHS and RHS. Once again 2 Na, 2 Na. 4 hydrogen, 2 plus 2, 4 hydrogen. 2O, 2O. Now it is balanced. So this is the way of balancing the chemical equations. See once again, all the 3 questions are done. Now there is one more question given, question number 3. Question number 3. Write a balanced chemical equation with state symbols for the following reactions. In the previous class I told you, in order to make the chemical equations more informative, we also write S for solid, L for liquid, then AQ, aqua for solution in water, etc. So here you are asked to write this also so that the state of each reactant and product is also visible. First one, solutions of barium chloride. Solutions of barium chloride and sodium sulfate in water. Solution in water, what does it mean? Aqua. Barium chloride and sodium sulfate. So, first one, barium chloride, BaCl2, solution in water means aqua, plus sodium sulfate in water, Na2SO4 in water means again aqua, gives react to give insoluble barium sulfate. Insoluble barium sulfate. Barium sulfate solid, that is BaSO4 S plus solution of sodium chloride NaCl. Solution means L, liquid. So I have written the formula of reactant and product. BaCl2 plus Na2SO4 gives BaSO4 plus NaCl. Now the second part of the question is balancing. Take each element, count the number of atoms in LHS and RHS. Ba equal Cl2, only Cl. Here there are two chlorine atoms, here there is only one chlorine atom. So how can we make chlorine atoms equal? By giving 2 here. Cl2, now it is Cl2. Na2, yes. Now Na is also 2. SO4, SO4. Now count the number of atoms in LHS and RHS. You can see the number of atoms of each element in LHS and RHS are now equal. See once again. So by putting only 2 there, it got balanced. Now second part. Sodium hydroxide solution in water. Sodium hydroxide solution in water. So what will you write? NaOH is sodium hydroxide. Solution in water means aqua. Plus reacts with hydrochloric acid solution in water. Hydrochloric acid solution in water means HCl, again aqua. Gives to produce sodium chloride solution and water. Sodium chloride solution and water. Sodium chloride solution, NaCl, L for liquid, and water. Water is H2O, this is also L. So symbolic representation is over. Chemical equation is formed. Now balancing. Count LHS and RHS. Na equal O, only 1. Here also 1 O. H plus H, 2H. Here also 2H. Cl, it is already balanced. While counting the number of atoms of each element in LHS and RHS, you can see the number of atoms are equal. So this equation is already balanced. So this is about balancing a chemical equation. So the first part of the chapter is over. Chemical equation and how to balance it. Now we are proceeding to the next topic. Our next topic is types of chemical reactions. Types of chemical reactions. We are going to study 5 types of chemical reactions in this chapter. That will be the end of the chapter. Which are these 5 types of chemical reactions? First one is combination reaction. Combination reaction. What does it mean? When two or more substances combine together to form a single substance as product, it is called combination reaction. Second one is decomposition reaction. Just opposite, to decompose. Splitting up of a single substance into 2 or more substances. Such reactions are called decomposition reaction. Then displacement reaction. A more reactive metal can displace a less reactive metal from its salt solution. That is called displacement reaction. Now, double displacement reaction. In double displacement reaction, the ions will interchange with each other. 2 reactants will be there. These reactants will interchange their ions between each other. It is called double displacement reaction. And the last type is oxidation and reduction reaction. Oxidation means addition of oxygen or removal of hydrogen. Reduction means removal of oxygen or addition of hydrogen. I gave the simple definition of each of them, but I will come one by one with examples. So there are 5 types of chemical reaction: combination, decomposition, displacement, double displacement, oxidation and reduction. Once again I will explain each of them one by one with example. I am beginning with the first type, combination reaction. So as I told you, In combination reaction, two or more substances combine together to form a single substance. So many examples are there. One example, H2 plus O2 gives H2O. Combination of hydrogen and oxygen gives water. Combination of carbon and oxygen gives CO2. Combination of sodium and chlorine gives sodium chloride. So many examples. Their equations are not balanced, only to make you understand. This type of reactions are called combination reaction. Two substances combine together to form single substance. This is not necessary that always there must be only two. It can be more than two. But here in the product there must be only one. Another example, have you heard about quicklime? Quicklime is CaO, calcium oxide. When water is added to quicklime, then we get CaOH twice, calcium hydroxide. It is known as slaked lime. So CaO is quicklime. The lime in that white form, the lime that we use to put on the track, that is quicklime. When water is added to quicklime, one more importance of this reaction is that it is an exothermic reaction. When water is added to quicklime, lot of heat will be liberated and you will get an emulsion of calcium hydroxide. It is known as slaked lime. S-L-A-K-E-D, slaked lime. Slaked lime is an emulsion of quicklime and water, which is used for making pan, and it is also used for whitewashing the floor, that is slaked lime. This is also an example of combination reaction. CaO, quicklime, adding water gives slaked lime. Now you might have heard one more related to lime. When lime water is passed through the test for carbon dioxide. Test for carbon dioxide is that when carbon dioxide is passed through lime water turns milky. Have you heard about this reaction in smaller class? You might have. This is also an example of combination reaction. CO2, carbon dioxide, is passed through lime water. Lime water is CaOH twice. This is lime water. Carbon dioxide is passed through it. Then that clear lime water will become milky. Reason, this lime water, that is slaked lime, is converted into CaCO3, calcium carbonate. Actually this calcium carbonate is a white precipitate. Due to the formation of this white precipitate of calcium carbonate, that lime water turns milky. This is also an example of combination reaction. So the first type of chemical reaction is combination reaction. All these are examples of combination reaction. Addition, combination of hydrogen and water to oxygen to form water. Carbon and oxygen combine together to form carbon dioxide. Sodium and chlorine combine together to form sodium chloride. Quicklime is added to water to form slaked lime, CaOH twice. When carbon dioxide is passed through lime water turns milky. All these are examples of combination reaction. You can also try many more such examples where two or more reactants combine together to form a product. So I think that's all for today. Please revise the topics that are discussed in today's class and ask your doubts in the comment box. Till then, take care. See you. Bye.